Okay, the next question is when you have the table. Okay, in this question, you are given a curve. In the next question, you are given a table. So the manufacturer is too lazy to give you the curve. They give you this table. Okay, so what happens if you are given this table, right? You have a pump. This is the condition. Still the same, just changing is the friction factor. You see the friction factor now is 0.032. Minor losses and elbow from the valve and elbow is negligible. Right? It depends on whether in your case the minor losses is negligible. Sometimes the major losses is also negligible. If the pipe is very short, you don't care about the major losses, right? You just care about the minor losses. Especially if you have elbow and you have valve or filter. Filter is the worst. Right? The KL of filter can be from 30 to 80. So if you put a filter on your water flow, it's really it's really obstruct the flow. You get a lot of losses. Okay, the pump characteristic is given in the table rather than in the curve. It's given in the table. So what you need to do, same. You do that. You know, in this case, P1 is equal to P2, which is equal to P atmospheric or zero gauge. Why I put zero gauge? Because some of you may say it's zero pressure. No, it is not zero pressure. It is atmospheric pressure. Zero gauge. Delta Z, you know it. Then you can calculate HS. You get this. Then you can convert from V squared to G into Q squared. Okay? Now the challenge is the next one. This is your system equation. This is your system equation. And this one is your pump equation. This is your pump equation. And this is your equation. So what will you do is, let's say your system equation, HS is equal to 6.1 plus 20.1 Q squared. This is your system. Your pump is this. So what will you do is, you just put another one here. You put another row. Put HS. Put HS. And you calculate it. For Q0, HS will be 6.1. You compare. This one and that one not match. Next. Right? 0.2. HS and HP. Is it match? No. Goes next. Okay. Until it close. But you know, somehow after it closing, it will dispatch again. So you know that the operating point is between those two. In that case, you need to split that. You need to do some more calculation. Okay? That is your system curve. This is the pump characteristic curve supplied by the supplier, by the manufacturer. You goes that. Now, you see, if you compare, because if you realize from the plotting, you know from the plotting, it always that the pump is having this curve, right? When you have high flow rate, you will have low pressure. When you have high pressure, you have low flow rate. But for system, if you want to have high pressure or if you want to have high flow rate, you need to give them a lot of pressure. Just like training you guys. If I want you to be a good fluid mechanic engineers, I need to push you a little hard, right? Then you can move faster. If I just do, not move. Right? If I kick you, move, you will move. So this is the system. Right? The more you need, the more pressure you will need. Right? The more you expect it to move, the more pressure you need. Okay, so you can see here, the system, when you want the flow rate to be higher, you see that the pressure head is higher. Whereas for the pump, if you ask the pump to move faster, then it will have a lower pressure. Right? So you need to find which location those thing is matched. So you can see here, this one 17, this one 16, right? After that, it goes down, it goes up. So you can see it's in between these two, right? So what will you do next? You play around with the number, you increase it a bit, and see here. You compare. When you have HS equal to HP, then that is your operating point. Okay, once you get the operating point, in this case the Q is 0.73. So the corresponding head, how do you have the corresponding head? If you get this 0.73, you use those equation or the equation from here, it has to be the same. Okay, so at the operating Q, at this point, HS is equal to HP. Clear, ladies and gentlemen? Okay, so once you get that, you can calculate, because you get your Q, right? You get your Q, you can calculate your HS. When you calculate your HS, you can calculate the sub power. Okay? So that one is if you are given a table, right? In your tutorial, it is given in terms of equation. Okay? So what happens if you are given the equation like that? Very simple. You just need to calculate HS is equal to HP. In this case, if you need to use this pump for these particular cases, this is your H system, right? 6.1 plus that. So you just put it 52.01.17 times 10 to the power of minus 3 Q square is equal to 6.1 plus 20.1. As simple as that. So you just equate this, equate that, got it. Okay? If you do the calculation correctly, once you get your Q, right? Let's say you have Q is a meter cube per second. When you calculate HS, you will get the same when you calculate HP. So both has to give you exactly B meter. If that is not the case, your calculation is wrong. Simple, right? Right? This is in your tutorial. Okay, so I give you all. Using the table, using the curve, and also using the equation. In equation 3, you will use the curve.